Hello everyone, welcome back to Dragonfly Engineering. So this week is part 2 of the Mastercam 2024 milling for beginners, and this is 5-axis milling. Last week I showed the introduction to Mastercam and how to load parts and things, and you can see a preview in the bottom corner. So if you haven't seen the first episode, I recommend checking that out first. Otherwise, enjoy the show. So let's simulate this now and see what we get. But I only had that one operation selected. So we'll exit out of this and then rerun everything by clicking Toolpath Group 1 and then Simulate and then Play. We'll see if we gouge or do any nastiness when we machine this profile out. I guess we did a little bit, but that's outside of the part, I believe. Oh, no, it isn't. All right. Anyway, yeah, it was outside of the part, it seems like. So I think we're good. I'm not going to fuss over this forever. But I do need to drill these back holes because you can see I just have the spot drill right now. Oh, and this hole needs to be drilled as well. So I'll add in the rest of these drilled holes, and then we can post this operation to the mill. All right, so we're out here at the Haas 5-axis. This is the UMC 750 SS. And I have a new tool that I'm going to load. This is the pilot drill for the M5 tap, which goes into the end of the part. We didn't have this loaded into the tool carousel and preset at the mill 0 or the tool offset position. So we'll go through and do that real quick. So we'll load this tool. Hopefully you can see that. And I've already selected tool number 3. So this is offsets and then tool offsets. So there's tool number 3, and then we're gonna come over and see which pocket it's in, which, let's see here, pocket number 37. So let's make sure pocket 37 is actually empty in the mill. All right, so you can see there pocket 37 is empty. We've got 40 tools total in this tool carousel, and I'm just about full on tools. So at some point I'm gonna have to start swapping out drill bits, I think. But anyway, 37 is our pocket, which corresponds to tool number 3. And the pockets usually change as tool changes occur. So it's a continual updating, I guess, lookup table in the mill itself. Because of a swing arm tool change, there's not dedicated pockets in this architecture. All right, so I'm going to go to the MDI, which is the single command input portion of the controller, and we'll say M6T3, enter. So M6 means change the tool, and the tool number is 3. And with the door closed, we will hit cycle start to change the tool to the empty pocket, which is pocket 37 or tool number 3. Okay, so now I can open the door up as long as nothing's moving inside. And we will load tool number 3, lining up the tangs and the spindle, and we'll hit the tool release button. And now tool number 3 is in the mill. But we still have to set its tool height position. I might clean this window off a little bit. All right, so there's our tool ready to be taught its height in the mill using that tool setting stage down there at the bottom. So if we go back to offset and we scroll all the way to the end, probe type. So probe type for this tool is going to be length non-rotating. That means we're going to probe how tall the tool is relative to the spindle. with the tool not rotating, so that, you know, because we don't have multiple cutters, it's just a drill bit tip. So to do that, we will hit the, let's see, tool offset measure button, and it's asking me probe selected tool, number 1, and then it's saying basically run this in the MDI, and when I hit cycle start, a little tool measuring program will appear in the MDI window. So I will do that. Okay, so I'm going to hit the cycle start button, and the mill will do its sequence of measuring the tool height by slowly dropping down until it touches that probe stage at the bottom. And that was it. So now we are ready to run this part. I have already loaded the blank stock based on the stock size of our Mastercam model. So here you can kind of see our setup. And these set screws I've already tightened down on front and back, so we are locked in and ready to go. So let's start the program and run our Mastercam toolpath. All right, so we are over at the mill, and we've got our stock loaded. I've loaded the new program. I copied the program, the G code that we created with Mastercam's post processor, and I stuck it on a USB stick, loaded the stick, and then through the interface here, I copied the program off the USB stick onto the memory of the mill. So we are going to run this at about 60% feed and 25% rapid, since this is a newer program. I have done some pre-testing, full disclosure since this is YouTube, but there were a few changes that I made. The 3D fancy toolpath had an issue. The feed rate was given as 0 for some rapid motions, and the mill didn't like that. So I updated to a simpler open edge pocket, like a old-timey type of CNC pocket instead, for the facing out of that notch in the front. Anyway, so given that, I'm still going to run it a little slow and keep my finger on the feed hold button as the stop if I see things are getting out of hand in there. Okay, without further gab, let's start. So I'm going to be looking in there, and I'll hit cycle start and then be ready to stop just in case. And it's doing a tool change, so let's flip the camera around. And I'll hit feed hold, and we'll figure out the whole camera situation here. All right, and I will hit cycle start. We'll probably, yeah, okay, here goes. Okay, that's not bad. I gotta make sure that we don't build up too much aluminum on this end mill. So we're facing the top. This is the first operation in our CNC program. I guess whenever I see steam, which is probably a lot of the time, I'll spray it a little bit. Though the cooling off, you can hear the sheet metal rattle a little bit. We're going to do our first rotation here. And then we'll face the back side of the part. So in simulation, we made sure that we weren't going to cut into our base fixture there. It looks like we're doing a finish cut too. This is a spring pass, which isn't really necessary when you're cutting with the tip of the end mill, but it compensates for any flexure in your tool holding or your work holding. This is that clearance notch that I added for the previous pocket because of some of the rapid travels. We're kind of plowing through the stock between the usable stock of the part and the stock that's clamped into the fixture. This is the finished cut pass on the sidewalls. Nice little ring to it. All right, now we're going to do some drill center spotting. Again, I got this running at about half speed. I think I can speed it up. I've proven this part out. Gotta work on my approach. That's more full speed. We've got a programmable nozzle that can point the coolant right at the cutting area of each tool, but sometimes it fails, so I may have to buy a new one of these programmable nozzles right here. It's probably a couple of grand. Here we're drilling some pilot holes for some M4 threads. I'm going to slow this down. You saw the nozzle moved its spray location. All right. That's actually just a through hole. Oh no! Yeah, drills are a problem. All right, now we're going to do some pocket machining. Is this a 4 pocket replace the silver version? And the finish too. That's a sidewall finish. This is tap pecking. Probably not necessary. I think it's maybe 80 thousandths per peck. So the toolpath post processor that I actually had to buy with Mastercam figures out all of this unlocking and locking of the stage. So it brings the stage back to 0 every time it does a tool change for like kind of default safety. So I'm not programming these kind of moves in. This is all done with the post processor, which basically takes the commands from Mastercam and then turns it into useful commands that the mill will safely execute. Like this move right here. All right. This is a chamfering, which is new. So I am going to slow this down a little bit. Mastercam does have a nice chamfering algorithm that allows you to deburr your edges without having to spend all day programming it. It kind of finds edges for you. Nice. We can go to full speed. I guess this is full speed. I backed it off a bit. Oh wait, no, this is full speed. Ooh, didn't like that. There we deburred that drilled hole, or that tapped hole, I think. All right, now we're gonna part the part off. With a 1/4" end mill. So now we're kind of removing our almost fully machined part from the base stock. All right, so now it's just kind of teetering on some sheet metal. Those chips may cause a problem. And that is it. Program is done. There is a little bit of a second op. There's a tool radius right here that I'll have to cut. All right, so here is the finished part. There's a little bit of chatter here from the chips that were stuck in this cutoff slot. But normally when I'm running coolant and not shooting video, that won't be an issue. This edge isn't important either. And in fact, we can clean it up when we cut off this flash and machine this square corner, the tool radius corner. But that's the whole operation of tool path generation with Mastercam and machining with the 5-axis mill. There's a lot of steps that I couldn't cover everything, so this is by no means a complete like tutorial, but it's more of an overview because there's things like checking your G code for safety features like one work coordinate offset and things like that need to happen, which I did off camera. But anyway, this is it. Hope you enjoyed.